Oh, hi there! I'm Matthew Francis Lando, the project manager of Red Aerospace. So what's up today?
My name is Grace On, and I am the Deputy Program Manager of Red Aerospace.
Hey, I'm Brian Lane, the Chief Scientist of Red Aerospace.
Manufacturing Engineer for Red Aerospace.
I'm a Media Specialist for Red Aerospace.
The Systems Engineer of Red Aerospace. Test Engineer of Red Aerospace.
Mechanical Engineer of Red Aerospace.
Programming Team for Red Aerospace. Chief Strategist of Red Aerospace.
Red Aerospace.
Red Aerospace.
Red Aerospace.
Red Aerospace.
So we've got this rover, right? And it's been sent out by NASA on one of Mars's moons to collect data on life. But all of a sudden, this huge solar flare comes in and knocks out almost all communications and functionality. But that's where we come in. We've invented this small, spherical robot to fly in the dense atmosphere of 2001 KX-76, and it is fully equipped to revive the broken rover.
We sat down with a whiteboard and a dream. We brainstormed and came up with the polycarbonate spherical robot as a product to revitalize the rover.
After implementing a detailed design matrix, the team began designing the robot. Red first looked at other types of machines, such as the small RC helicopters, and admired the rotational direction and response time, as well as the maneuverability of the flybar and its propellers.
You can adjust it. At the end of the year, it's always spinning counterclockwise.
Like giving to each other before.
No, that's what the problem was. Yeah, I made it. That's quite the problem. Logo power. Always counterclockwise. There it goes.
After taking keen observations on the helicopter's design and functionality, the team got to work and began generating computer-aided designs, proposals, and working prototypes.
Red Aerospace is a great company, mostly because it's people. I believe that the team members on Red Aerospace have a very powerful synergy that most other companies lack. I mean, we all work together, we talk to each other even on our free time, we eat together on occasions. We just like to be with each other, and we have this powerful team composition that I think is unmatched by anyone, especially the Phoenix Initiative.
October 18, 2011 was our first critical design review. Red Aerospace generated a system performance specifications document which consisted of the team's plan of execution. In front of a panel of judges, the team presented the plans for design, manufacturing, testing, time management, and budget.
The team then proceeded on to the second milestone, the proof of concept. During this period, the team began the manufacturing and testing phase. Using the computer numerical control router, also known as the CNC, Red first cut 6 semicircles. The top and bottom of the robot were made flush by filing. For assembly, the team tried various forms of weld, but found JB weld to be the most effective. The drying process took over 24 hours.
Concurrently, the team created prototypes for the pod that would encase the robot. Red first aimed to solve the issue of controlling the direction of the pod once it reaches the apex. A 4-inch styrofoam prototype sphere was used to perform the various tests of seeing the effectiveness of tails of different materials and a parachute. During testing, Red saw that the tail stabilized the flight but did not prevent spinning in a lateral direction. The final test with the parachute showed the most favorable results. Red saw that the parachute will indeed keep the pod in the correct orientation for the robot deployment.
Soon afterward, a polyethylene hollow
hollow prototype sphere was ordered in order to conduct more realistic simulations. The team used materials such as door hinges, nails, a continuous servo, and rubber bands in order to simulate effective tests.
By placing size 64 rubber bands between the two nails used as anchors, the tension force between the hemispheres opens the pod when the motor unlocks the latch. A 2.5 by 1 inch gate latch is controlled by a continuous rotational servo, which can open the pod on command. The manipulator slides in and out of the hinge, which locks and unlocks the pod mechanism. We tested that when the pod is thrown at its apex, the pod will deploy.
Once the pod was purchased and modified, and the frame was assembled, the team decided to showcase these multiple tests for the proof of concept: wind speed, temperature, wireless communication, motor control, and pod deployment. Therefore, in preparation, the team programmed the robot and pod as well as run many tests to avoid mishap during the presentation. Well, we did much better than the last CDR. Carpal Authority quotes that we displayed technology beautifully. We hope to keep this momentum up for the third critical design review and for the following trade show.
Fighting!
By the third CDR, Red could still not achieve flight. The propellers were too weak to gain any thrust. The robot was 1 kilogram, but the available 10-inch propellers could not manage lift. Consequently, the flybar adapter and propellers would break off whenever we tested. To compensate for this, we have decided to begin manufacturing our own propellers out of aluminum. However, one complication is the curved surface on the propellers, and to overcome this, we have had to make a mold and fill it with wax, which we will hold the propellers in while machining.
In addition to this modification, the team came up with a newer model with a 13-inch frame. Though bigger, the robot is much lighter than the 9-inch model. The team learned that bigger the propellers, greater the thrust. Therefore, with this model, the team will achieve flight.
EDT taught me how to be a part of something much bigger than myself.
I learned a lot about teamwork and how teamwork helps get things done efficiently.
The biggest things I learned were how to delegate and the fact that a leader needs to he needs to know a little bit more than everybody else does.
I learned that anything could be achieved with a group of crazies.
I learned what it's like to work as an engineering firm and how crucial it is to function as a united team.
I learned how to CAD more efficiently.
I learned all about the design process. Hold on, okay, just edit that part. This project has shown me the types of experiences that I will encounter in the future as an engineer.
I like trains.
Diligence, responsibility, hard work, and determination are a key factor to one's rate of success.
This project has helped give me the determination to win.
Well, this is how we run our company.
On plants. I learned that designing something to work is a tedious process, but if you're persistent, it'll get done eventually.
I learned that if you have an idea interesting enough, then you'll always have someone ready to help you.
I
everything in this project.
You know, being able to motivate people to build such a cool thing, and then I've really learned, you know, how awesome it is to work with lots of people and lots of team management skills, I hope. So we've learned a lot, we've designed a lot, and this is our result, our one.